Does everybody understand what I just did? I took the equation. Let me just use the screen here because it will all be recorded. I just took this definition, which has to be true. Okay, this derivation has got to be right. Instead of mentioning post 2, which is unresolved, I put in my suspicion. My suspicion is post 2 may be just as simple as x is less than or equal to k. So I plug in my suspicion and I want to see whether it works out or not. Because if this is wrong, in other words, if post 2 cannot be x is less than or equal to k, this substitution operation will not work out. So I want to see whether it works out or not, because if it's working out, that means I have just found the loop invariant. Okay. So I want you guys to focus on what I'm trying to do rather than the mechanics of actually doing it at this point. Is that okay?
What if you don't have that gut feeling? Where did you get that gut feeling from?
Years and years of computer science. So this is not something I would expect you guys to be able to do. I will give you, if I will give you any questions about this sort of thing, I will give you the actual loop invariant, and you will just have to go through the steps to show that it does work out. That's all you're going to have to do. So you don't need to rely on a gut feeling that something is going to be the loop invariant. Okay, because it is really hard to get to the loop invariant. Okay, so now my challenge is to say, if I do carry out this entire substitution operation, can I make post 2 the same as x is less than or equal to k again? That is the whole thing. Okay, let me just write it down. If tag carries out the subst operation, can post 2 become x is less than or equal to k again? That is the question. Because if I can, then everything works out. If I cannot, that means my gut feeling was wrong. Does it make any sense? It's a consistency check. It wants to see whether my gut feeling is actually consistent with this entire system of equations. Okay, so from here on, it's going to be a bit messy, because I will just go ahead and carry out the substitution, which basically says x minus 1 is less than k, and then we have a big mess here. X minus 1 equals to 0, and k is greater than 0 because k does not mention x, so there's no substitution there. And then we also have x is, in this case, x minus 1 is less than or equal to k, and I need to make sure the parentheses are all matched. I might be missing one. Yep, I missed one. Okay, now we have a big old mess. So the first thing I want to do is to reduce the number of pairs of parentheses so it's easy to read. So we have x is less than k plus 1. Okay, and here we have x equals 1. Okay, x equals 1. And k is greater than 0. And then the whole thing, or x is less than or equal to k plus 1. Okay. And are the parentheses matched up? Why am I missing one? I think I'm missing one.
Yeah.
Yep, there you go. Okay, so here is the most important step. The most important step is to say, can I say that x is guaranteed to be an integer? Well, let's think about it. The pre-one is now saying that x is not just any value. I know x starts with a value of 0, right? And then if you look at the code, the only thing I can do to x is to add 1 to x. Does that guarantee that x will always be an integer, at least during this loop?
Yeah.
It does. Hmm?
Yes, because there are energies.
Right. Well, x starts with a 0 as pre-1, and the only thing I can do to x is to add 1 to x. So therefore, x can be 0, 1, 2, 3, 4, and up. It cannot be a fraction. Right? Okay, so we'll write it down here. Since x is guaranteed to be an integer, we can play a trick. The trick is to say that if x is less than k plus 1, means exactly the same thing as x is less than or equal to k. Okay, let's just stop here and think about it for a little bit. Is that really true? If I know that x is an integer and k is an integer, is it always guaranteed that if x is less than k plus 1, it always implies that x is less than or equal to k? Yeah, k is integer. K is an integer. X is always an integer. Okay, so this is okay. Everybody agrees. Okay. So once we have this little agreement, we can do certain things. We can say, x is less than or equal to k, and this whole big mess here. So we'll go ahead and just look at this big mess. And okay, we can keep that one the way it is. All right. Now this looks like a pretty big mess right now. And we'll use the distributive law to make it even bigger. Okay? Well, we are making a bigger mess because, let me see. Do we want to make it a bigger mess at this point?
Can't we simplify?
We can simplify it. We are trying to. I'm trying to figure out what is the best way to simplify it using using as a smaller number of steps. Okay. Now I think it is okay to basically safely assume that k is greater than 0 is going to be true all the time, right? Because it is in the precondition. And is there any potential that we might do something to k to make k not greater than 0? Okay, so what we'll do is we'll just make it a little bit simpler. In other words, we'll just kind of take this component out for the time being. In other words, we'll have a slightly simplified version of this just so that it is easier to deal with. Actually, we still need the other part. Okay. I'm just going to take this out. We will focus on this part first. Can we simplify this a little bit? Let's think about it. Okay, here I say, x is less than or equal to k plus 1. But what do I know about k? I know k is
greater than 0.
K is greater than 0. Okay, so are there any ways for me to simplify this part here, the part that is highlighted? In other words, does x is less than or equal to k plus 1, does it imply that x may be 1?
Yeah.
If you look at just this part here, x is less than or equal to k plus 1, and you combine that with and k is greater than 0. Does that mean that x may be 1? Sure. And this is a disjunction, which means we get to keep which side? The more restrictive side or the more general side? The more general side. It's a disjunction. It is an or. So if one side includes the other one, we will take the more inclusive side. Okay, let's just think about it again. Now I cannot erase this. Number line. Okay, here's my number line. I have 0 here. Okay, I know that k is somewhere on this side because k is greater than 0. So what this is saying, the first part is saying that x equals to 1. Okay, this is 1, and x is here.
X is equal to K. Could it?
Maybe. We don't know. It simply says k is greater than 0 and x equals to 1. That's all it's saying. The first part. This part here. The second part is saying x is less than or equal to k plus 1. We know k is at least 1, so k plus 1 is at least 2. And that implies k, all it is saying is x is less than or equal to k plus 1. The second part. Don't you think this part already implies the other part?
Yeah.
Yes? In other words, okay, let me just write the derivation here and see whether you guys agree that this is the case. This is what I want to do. Can I simplify this whole thing into here?
Yeah.
Well, of course, we still have to say k is greater than 0. Is that okay? No?
So, let me see if I understand this. Because x is included in the set of k, you don't need to say x equals 1.
X equals 1 is one of the many possibilities that are already covered by x is less than or equal to k plus 1.
Because x is a part of the set of k.
Because x equals 1 is already covered by this particular case.
Then k can't be 0.
K cannot be 0. K is at least 1.
That would make x.
So that would make x. But this does not say what is the minimum value of x. It simply puts a cap to what x can be. It is saying that x cannot exceed k plus 1.
That's not the same as saying x equals 1.
That is true. But does this case cover the other case? When I say x is less than or equal to k plus 1, does it cover the case that when I say x equals 1? Does 1, okay? So 1 includes the other one. The right-hand side of the disjunction includes the left-hand side of the disjunction. So we only have to keep the right-hand side because it is the more general side. Is that making any sense so far? Yep.
I'm still confused at how you got x equals 1 in the second line up there.
X equals 1 comes from the substitution. This is the result of the substitution. The substitution finds x equals to 0, this one here, and it applies the substitution. It replaces x with x minus 1. As a result, I have x minus 1, which used to be x, equals to 0. If you add 1 to both sides, then it becomes x equals 1. Okay? Are we okay so far?
Is
Yep.
x equal 1, that's going to be only the first time it comes out of that.
That is correct. Yep. Now, if I have something like this, can I simplify it even more? These are all conjunctions, right? Look, I just want you to focus on the first part. In other words, focus on this part here. Okay, just focus on the first part. This part. Yep.
You can get rid of x is less than or greater than k because it's included.
Yes, the other one. This time we get rid of the other one because this time we're trying to find the conjunction of two conditions. But we can see that one condition implies the other one. Right? Which one is more restrictive? Is it more restrictive to say that x is less than or equal to k? Or is it more restrictive to say that x is less than or equal to k plus 1? Which one is more restrictive?